Did you get anything settled, Bill, about 2 weeks from now?
Not yet.
Not yet?
See where we land tonight.
Okay. So what we'd like to do is we'd like to review, and let's go back and look at these flow diagrams and look at the what we're going to use these for is to try and understand what goes on during the interaction of the protocol. And you'll notice what's missing here is the SABM and the UA that started this whole thing off in the beginning. You can't just come to this point. But what they're trying to point out here is the fact that the DTE side, which we'll call KE0QA, and the DCE side, which we'll call W6OAV, I sent Bill 3 continuous iframes, and Bill acknowledged by sending a receiver ready saying that he's expecting number 3 next. Now I numbered mine 0, because remember, this is an IBM protocol, and IBM always wants to start everything out with 0, which is to them only logical. Never made an awful lot of sense to me. But I sent frame 0, at least I numbered it, right? And then I sent frame 1, and then I sent frame 2, and Bill says, okay, I received your 0, 1, and 2, all in sequence, everything is fine. The way he said that, he says, I'm expecting your number 3 next. So then I send number 3, and then Bill would probably send me a receiver ready 4 with the next received of 4. Yes?
What determines the spacing of when he sends the receiver ready? This time he sent the receiver ready after 3 packets, and next time he's going to send...
Well, first of all, okay, let me explain that when I get started here, I got control of the line. What I had to do before I could get started was to wait for the line to be idle. And there's a random timer, it's a random number generator that waits a random amount of time based on a parameter that's in the TNC, so we don't all start at the same time. So I waited this. I was a good citizen. I waited. I have my parameter set the proper way so that I wait the appropriate amount of time. I didn't hear anything on the circuit, so I started sending, and these probably came out one right after the other. In other words, they came out with maybe just one flag between them, because I had 3 iframes I wanted to send. Remember, I'm a fast typer. Yeah, just boom, 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 one right after the other. 3 information frames, and on this last one, I probably set the pole bit, or I'm sorry, the final bit to a 1, demanding a response, saying, that's all I got to send right now. I want you to respond to me. So then Bill waited his random amount of time and responded. What could have happened in between here is all kinds of other conversations, because remember, we're time sharing this frequency. What we're just showing is the interaction between these 2 stations. So there could have been other, yeah. There could have been other stuff go on too during that whole interaction. Yes?
You said max frame, going along with his question. Is that your maximum number of frames before
Yes.
you get an acknowledgement back?
Yeah, you have to be able to accept 7.
So
You have to have enough memory to be able to take 7 frames of 128 bytes. That's part of the protocol. Max frame is for your transmit. Has nothing to do with your receive. You have to be able to accept 7 frames.
If you have max frame set at, say, 3,
Yes?
does that not mean that, as you type fast, as you say, when you fill up 3 frames, you may be typing the 4th, but it will send 3,
Yes.
and then start storing, let's say?
Yeah. you're really not going to see this in a keyboard-to-keyboard operation. What you see is, when you see this kind of an operation, you see this more like a bulletin board. Or you'll notice the long message that comes out here when you connect to a node. Connected to node WG0N-7, and in parens, WG0N channel A, enter gateway, so on and so forth. So he puts this long message out. So that comes in more than one packet, more than one frame. That came in several frames. So maybe that wasn't that Dave was, well, Dave isn't that quick of a typer, but his machine had that, had that much stuff stored. What does happen from time to time, if you're on HF and you type in away and you send one packet, but you never get an acknowledgement from it, and you're typing away, and now you've got a second packet stored, so it's send packet 1, and it'll follow right away and send packet 2. And while all this is going on, you're typing the third packet. You wind up, having several packets stored up. They may be short, but nonetheless, this could happen in a keyboard situation on HF or on a very busy VHF channel. Yes?
Joe, if there's a mistake received, on, we'll say the third one there, do you have to send all three of them over?
We're gonna talk about all those possibilities. We're gonna talk about this one getting clobbered and this one being received, and this one making it and this one getting clobbered and this one received. Yeah, we're going to talk about all those situations coming up next. So you're getting, you're a good lead in, but we're going to get to it. Okay?
A little aside, but the relationship between an information packet and a line on the screen. Seems to me, since you can set packet length, if you set it less than, 76 or 80, maybe there's a relationship. If you set it more than 80, there wouldn't be, if you've got an 80-line screen, that is.
Remember, though, when you're typing, if you hit a carriage return, that automatically packetizes everything. So regardless of whether or not you have a 128 character packet, when you hit that return, it just became somewhat less than a 128 character packet, because hitting that carriage return causes, that's usually the enter key, or the thing where you want something to be done. And so it causes the packet to be sent. And so you may or may not use the full 128 bytes. Usually you don't. Usually the terminals require that carriage return line feed in order to come up on the next line. I know a whole...
You just keep typing. Does it depend on the program you're using, your communications program?
Yeah, you keep typing. Well, if you keep typing to me, I've got a TRS-80 Model 40 laptop that I use at home, and that one wraps. But you have to be really careful about your terminal programs, because there's a number of terminal programs, especially the VT102s, that come up configured to not wrap. And you need to, especially like Procom, you need to specifically go in and make them do line wrap. You need to set up the terminal, terminal setup. I can't imagine that any of these terminal emulators that you get, like Packet Gold and those, I'm sure all those must line wrap. But you need to be careful if you're going to use crosstalk or Procom or some of those. You need to make sure that the terminal emulator is set up to line wrap.
They don't wrap in the 81st character.
It just types right over. You just keep seeing the characters at the end of the screen changing. So you know that you're getting something past there. There was a question.
If pack length is set at 25 characters,
Yes.
and you type 30,
As soon as you hit the character As soon as you hit the keyboard for the 25th character, that packet goes.
But it doesn't tell you that.
Oh no.
Does it insert a
I'll
character?
tell you how you can tell. You start hitting backspace to erase characters. Like let's say you type 45 characters, you got pack length set at 40. You type 45 characters and you say, oh, I made an error on the 20th character. So you start backing up and he won't let you back up only to the 40th character. 41st character he'll take off the screen and leave the first 40 because that one's now packetized and as far as he's concerned, it's gone.
So it doesn't insert a carriage return line feed.
No, oh no, no. Mm-mm. Nope. Yeah, see, Dave could have had his pack like set to 10, and we would have gotten, you know, that many packets, but it still would have come out the same. Depending on how those all got chopped up, a couple of those packets could have been very short because it would have had a carriage return line feed or a carriage return that would have automatically packetized. So several of them would have been short, maybe real short, one character, but you don't know. Okay, good questions. Why don't we go to the next slide? Thank you. And this shows, of course, the complete operation between the two channels. This is where, let's just call them Station A and Station B. Station A sends the SABM, which says, I want to connect to you. And the UA says, okay, I accept your connect. I'm not busy. I'm able to receive and all of that kind of stuff. And so Station A begins sending packets. Remember, we start numbering packets. This is our sent count. And remember that an iframe can also say receive count. So we send 0 and we expect, from B we expect 0. We send 1 and still expect 0 because we haven't received anything. So B says, okay, I got your 0 and 1. I expect number 2 next. So we send number 2, we send number 3, we send number 4, and he comes back with a receiver ready 5 saying, I got your 2, 3, and 4. Not only that, I got them in order. Everything is just hunky-dory. Now understand that there's some time, you know, there's some timing that's going on in here. And part of the timing may be just circuit activity, to, you know, where other stations are talking. So this is pretty pristine when you look at it this way. But when you actually listen to the circuit, it can have all kinds of things going on in between. Any questions? This is really just an amplification of what we looked at before, showing the original connect, the UA, and all of that kind of stuff. Okay, next slide. Can we give that little side thing to one of these folks here? There we go. Thank you. There's 3 timers, and rather than spending a lot of time talking about the T1 being an acknowledgement timer and a T2 being a response delay and an inactive link timer, let's look and see on the next slide what these actually do in real life. I like working off of these things here, because here's this talks about the T1 timer, and when I send a SABM, I start my T1 timer, and that's Um, now, Bill, the T1 timer is normally a 3-second timer. So if you don't get a response within 3 seconds, and this on the PK232, this is called FRAC, F-R-A-C-K. That really is the T1 timer. So when I send out a SABM, I'm going to wait up to 3 seconds to receive this UA. As soon as I receive it, I'm going to stop my T1 timer, and that SABM has been satisfied. When I send out this first iframe, when I send out frame 0, this is shown where, and I don't know how this can happen, but this is showing where he's going to send me a receiver ready at the same time that I'm transmitting my frame 1. Well, this will work if you're on a full duplex line, which in regular X.25, that's the case. That really does work that way. You can be sending frame 1, and he can turn right around and send you an acknowledgement at the same time that you're sending the next frame. So you send 0, he can acknowledge number 0 by saying, I'm expecting your number 1 next, during the same period of time that I'm sending number 1. But you'll notice here that I start my T1 timer as soon as I get this receiver ready. Back, I stop my T1 timer, and I immediately restart it because this frame is now outstanding. And when I don't get an acknowledgement within that 3 seconds, I've got to do something. And the way I do it is I use a receiver ready as a demand for a response. And I set my P bit or my poll bit saying, I really want you to respond to me. So I send a receiver ready, and he sends a receiver ready back with the final bit saying, here's my response, and I'm expecting number 1 next. Well, I already sent number 1, so he's saying that he never got my number 1. So I resend number 1, start my T1 timer, and hopefully he will acknowledge it this time. If he doesn't, we go through this operation again. My T1 timer expires. I send a receiver ready saying, tell me where you are. What's going on here? Why didn't I get an acknowledgement to this frame that I sent you? Yes?
The F after receiver ready 1 stands for...
Oh, this is final. This is, remember that 1 bit? It's the same bit. It's the same bit on this receiver ready. It all depends on whether you are the demander or the responder. If you're going to respond, that bit is called the F bit, or the final bit. If you're the requester, that's called a poll bit. I'm polling you.
What was the other bit? The pole bit and the...
Final. Yeah, you'll see it referred to as the P/F bit. It's the same bit. It's just whether you're in a demanding or a... I got a smart remark, but I'm not going to make it. All depends on whether you're the demander or the responder. If you're using this to determine which receive, because at this point he really doesn't know if he didn't get a response back. Now, does that mean that he didn't get the frame in the first place, or didn't we receive the response? Either one could be okay. This could just as easy have been a receiver ready too, if for some reason that response got clobbered.
Is packet radio simplex?
Mm-hmm.
Duplex?
Well,
Simplex.
yeah, it's balance mode. It means I'm going to wait till the channel is clear.
Then can that happen that way? That you would send that one
No,
before
no.
you receive the acknowledgement?
Now, see, this is assuming that these both started transmitting at the same time.
Hard to time share that way.
Yeah. If I started transmitting at exactly the same time that he did, I wouldn't be able to receive his response here, right? And we're assuming that he received his response. So, from that respect, the slide is maybe just a little off, in as much as it's explaining a full duplex circuit rather than the half duplex or wait until the channel is clear type of operation that we're used to in packet radio. Yes?
On your TNCs, you have a full duplex parameter. Should that be set off then?
No.
Or on?
That's whoops. The half duplex, full duplex is for, at least I'm thinking that it's for whether you want feedback or not to your terminal. Yeah, you don't want it in half duplex mode, because you're going to get feedback.
If it's in half duplex, you get double letters or something.
Yeah, precisely. Okay, let's go to that next slide. And here we see the use of a receiver not ready. It's used as a positive response. In other words, it acknowledged the frames. Let's look and see what happened. So up here there was the SABM and the UA, and we're assuming we came into this conversation kind of in the middle. So station A here sent an iframe. They sent 0, we sent 1, and at that point he stopped, and the B station sent a receiver not ready, and a receiver not ready is like a receiver ready in as much as it does allow you to be able to acknowledge, and he said I'm expecting number 2 next. So he said, I got 0 and 1, but don't send me any more. My buffer is full, or for some reason I can't go any further. So I accept your receiver not ready, and I wait, and I've got some more iframes that I want to send here. So I sent a receiver ready with the pole bit set, and he responds back to me. Since I had the pole bit set, he's got to respond to me, and he sets his F bit saying, and in this case he sends me a receiver not ready saying, I still got your 0 and 1 and I'm expecting 2 next. At some point later in time, he became unbusy, his buffer printed out or whatever happened within his TNC. He's now ready to receive, and so he sent a receiver ready on his own saying, I'm ready to receive now. So you see how a TNC can pace the other end.
Is one of those timers the thing that determines when you sent RR0 the first time? It says a timeout
Yeah.
occurs.
Which timeout is that?
It's T1.
Yeah, we're still talking about the T1 timer. So when I receive this receiver ready, I come out with my iframe, and we would go on then with our conversation. Okay, we're going to jump into what happens during some of these error conditions. And we look at the next slide. So what happened here is we've got the same 3 frames that we seem to have always ready and waiting from station A. And this time he sends 0. So we had the SAB and the UA up here somewhere. We're looking at this conversation somewhere in the middle. He sends number 0. Then he sends 1, but 1 for some reason, because of noise or interference on the channel, doesn't get here. In other words, what happened was the frame check sequence, remember that sequence, the 2 bytes at the end, doesn't match the information preceding it. And when that happens, regardless of whose call letters are in there, regardless of whether it's got the P-bit set, or regardless of any of those sorts of things, he discards it, because he can't depend on any of the information in there. So he gets 0, okay. 1 goes away, but he does get 2. Well, that's an odd situation. You know what really would be nice is if you could have a protocol that said, I got 0 and 2, but I need number 1. Because what's going to happen here is he's going to send a reject, and a reject frame has got a, it acts kind of like a receiver ready, but it's for this particular case where you do get some of the frames good. You do get a good frame here, and you know that you need to respond and tell him something, so you say reject, I'm expecting number 1 next. So what he's saying is resend 1 and any other frames that you had. Let's say that we had max frame set to 7. We send 0 and 1, and 1 gets clobbered. We send 2, 3, 4, 5, and 6. We got 7 frames, and he gets 2, 3, 4, 5, and 6 okay. And then station A stops. This is still the response that he's going to send. He's going to send me number 1 through whatever. So you have to start over from the last good received one. Would be kind of nice if we could just say, yeah, I got 0 and 2 and 3 and 4 and 5 and 6, but not number 1. But right now the protocol doesn't allow us to be able to do that. So we have to start all over from scratch. That's why on a channel that's particularly bad for noise, like HF, you need to keep your max frames to some amount lower than 7. Otherwise you run into these situations where first one makes it, or maybe the first one doesn't make it, but the second, third, fourth, and fifth do, and he's going to tell you to resend the whole thing anyway. And you see that going on HF channels if you ever monitor, where you can hear better than the person he's transmitting to. You see him resend those frames. Several frames he winds up resending time after time after time.
Something. If you're going to receive everything that's on that same frequency,
Oh,
whether
yeah.
it's meant for you or not.
That's right.
So if you receive, let's say somebody's transmission that wasn't meant for you, but if it failed parity checks, you screw you up because you don't know whether it was meant for you or not.
No, because if the parity doesn't work, I throw it away anyway.
You mean it is even checking parity on ones that are not addressed to you?
No.
No. I mean, we've got a
Well, if you have it set for all
problem there.
monitor, right?
Yeah, if you've got it set to monitor, then it's going to, yeah, yes. But under normal operation, yeah, if you've got it set to monitor and you want it to monitor only good frames that you receive, which is normally the way that you set it, you know, when you don't want it in junk mode. Yeah, it's decoding everything, and as long as that frame check sequence is correct, it'll throw it up on your display. Yes, Liz?
Joe, isn't there parameters you can set to where you have to recognize every one before you can go to the other one? Otherwise, you have to be recognized number 1, accept it before you can send.
Yeah, if we had max frame set to 1, you would send 1 frame, wait for an acknowledgement. If you don't get it, you send the receiver ready.
That's what I need to think.
And that's kind of the way that things run on HF radio. Usually you set your max frames to 2. And what happens during either a very busy channel or one that's got a lot of noise on it is you wind up sending a packet, waiting for an acknowledgement. You don't get it. T1 timer expires, send a receiver ready. And that's why things are so slow on HF, or at least appear to be slow. Yes?
The TNC, I'm trying to visualize what's happening inside of it. Does it have a place that it backs up the packet that was just sent so that if it gets called for again, it has it available?
Yeah, it doesn't throw anything away until it gets the acknowledgement. When this reject comes in and said, I received your 0, I'm looking for number 1 next, he can throw 0 away because he knows that this end got it. He can wipe it out of memory and start writing a new packet in its place.
So it sends the packet and also stores a duplicate copy.
Oh yeah. Yeah, he doesn't get rid of anything until he gets the receiver ready. Or in this case, this is a positive response. This is one of those things that allows you too to be able to keep that circuit going a little bit quicker. Because, you know, if I don't get this one, well, I'm not going to respond, you know, I'm just going to sit here, you know, whatever. This one here is, I can't use it, so even though I get it, I still throw it away. I got it, I received it good, I received it perfectly. The frame check sequence matches, but I had to throw it away. That's okay. I'm going to tell them right away that I need to see number 1 and number 2 again. Yes?
On VHF, where is the trade-off between max frame 1, which means you're getting a lot more acknowledgments, and max frame 7, which may mean that you have to send 6 frames over?
I normally run with max frame 7, but it's really not so important from my end because I honestly can't type that fast anyway. Even though I brag about it, there's no way in heck I can type that fast. But you're not necessarily being a bad citizen on VHF, provided that the circuit is not real busy. When the circuit gets busy, you would be a good citizen to reduce your max frames. But I don't think, Bill, what do you think as far as VHF max frame?
Yeah, if you're just typing away, you know, max frame of 7 is fine. If you're uploading a file to the Friends TNC or a BBS, then you probably would want to cut it down to about 5 or so, and run pack length at about 80. But that's basically true. HF is a different story. We talked about that.
As long as you're using the normal protocol, you're running through the normal timers to gain access to the line, that you send your 7 packets and you wait for an acknowledgement. You wait T1 timer time for an acknowledgement. And that the other station is waiting for its normal random amount of delay. You're really not being a bad citizen because everybody has a chance at the line. We have a little bit of a conflict with some of the parameters that are set up in TCP/IP when they do file transfer, and they never let you have access to the line. And that's not a fault with TCP/IP, it's a fault with the way that it's set up. So it's just a matter of the way that it's set up. Anyway, so you understand that if one of these gets clobbered, you need to retransmit in any others that follow. But we get this far and we can, in fact, go. Yes?
If I've sent my SABM, I've received UA,
Yes?
and I'm into my information, and I'm giving him my life history, I'm typing away, how much of this am I going to be aware of? Am I going to know that something's been rejected?
You might when you can't get through and your buffer is full. You've reached your max frame, and now maybe you want to get in and look and see what's going on with the circuit when nothing seems to want to get through.
So you should...
Yeah, you need to be aware of these things, but under normal circumstances, that's all transparent to you. Yes.
Joe, if you decide you're having a lot of trouble and too much noise, we'll say on HF, and you have this situation, can you cut it down from 1 to 7? Can you chop it off
Now,
about half of it?
No, once the packet has been formed,
You can't change it.
you can't change it. No, yeah, boy, I've done that too.
You could, huh?
Yeah. You know, you got the parameters set in it for VHF, and you go over to the HF side, and you type this horrendously long line, right? So you got, you got an 80 character line, and the circuit is really bad. You really should be running about 20 character packets. You don't realize that until he disconnects because he can't get this 80 character packet through. So then you need to reestablish the connection, make sure that your pack length is 20, and start all over again. So yeah, I've tried that. It doesn't work. Once the packet's there, he's going to send that Hummer. That's all there is to it. Yes.
If you were using multiple digis, would you want to use a smaller max frame so that it doesn't have to resend X number of packets through each digi?
Yeah, we're going to talk you out of using those digis anyway. Right, Bill? Yeah. Yeah. You know, and Bill will bring this out. Bill's going to talk at some length of connections and just what kind of problems a digi can cause in terms of circuit usage and so on. If there's any way around it. I mean, digis are really nice. They really are. They allow you to be able to talk through to some people where you normally couldn't. And in those circumstances, you're locked in. There's nothing else you can do. But if there's any other way to do it, and Bill, you and I have seen it. We've seen guys use 6 or 7 digis when they could have connected through 2 nodes and handled things so much more efficiently. Because once you give it to the node, you're done. You can forget it. He's going to get it there, or he'll let you know that he didn't get it there. So I don't mean to, but yeah, and Bill will talk about, what you need to do with those, with that digi situation, and you need to cut back on your number of packets. You need to cut back on its length because it's now got, a factor of 2 times more probability that it's going to get clobbered.
The digis don't set the P and F bit, right?
No.
So it has to go through the whole chain to the receive station.
That's
And then
the
all the way
whole,
back
that's
to-
right, precisely. And that's wherein the problem lies. And every time that you digi, you have a possibility of it getting clobbered, even on VHF. Well, Bill, you've got some numbers too that to back it up. What the odds are of getting from one end of California to the other. The odds if you don't run with nodes are impossible, and with nodes it's not only possible, it's done every day. This is, does that mean I'm early, Bill? Why don't we take a 10-minute break?
Dick here show you a little neat thing he just picked up. Show you some of the things that are coming out.
This is a TNC with a 40-column printer. And it's available, I picked it up through Henry Radio, on sale for 99 bucks. So, it's pretty good. I've still got to learn how to run the thing yet. But,
Dick, that works that works VHF only? Can you run it HF?
I don't know.
That would be the greatest thing for mobile radio ever, for HF mobile radio. Wouldn't that be great?
Print's too tight, too small.
Well, it depends on your age.
For $2, you get the big old magnifying glass.
I can say whatever I want because he's riding with me.
Well, that's super.
So, I've got to learn how to dump the buffer. Do you know how to do that with these things? Because if you listen for a little bit,
it all goes to the damn printer.
Oh, yeah.
The tape comes spewing out, and you turn it off, you unplug it, you turn it back on, and it just keeps right on where it was going.
Yeah, that could be expensive.
We'll give you an update in a week or two.
Once you're plugged in, you're plugged and full. It's still in there. Anytime I like to store it, brain.
It's not back to paper storage.
You've got an 80-pound roll on your back.
Jack, what you don't know is the paper's $50 a roll.
That's why they can sell the printer so cheap.
Yeah, first one's free, kid.
Well, fortunately, they can order them out of the book, and the paper is not expensive on thermostat. I found that out today. It was an early purchase, but I found it out.
How much is that paper?
Retail was like $7 for a package of 5 rolls, which is
Well, the way you're talking about how fast it's been made, like
thermal paper.
Before we get started, I know this is tough to read, and hopefully next week we'll have the LCD overhead that can project up on the screen. But again, to show you what you can do, I connected to W0TX, which is the Denver Radio Club gateway that interconnects 145.01 to 14.103, 20 meters. I asked it who it could hear. We won't worry about that now because we're going to cover this. But anyway, I told it to connect on 20 meters to KS8L-7 in Ohio. Came back here and said link made, connected to node KS8L, channel A, the multiband QSO converse mode. So down here I said, okay, now connect me to a node called CWQSO on 2 meters in Ohio. It came back, said link made, QSO, Canal, Winchester, Ohio, and I'm now on a conference bridge there. So we're sitting here on 2 meters with a couple of watts, going through the gateway, out to Ohio, back onto the 2 meter system to a conference bridge that has inputs on 10 meters, 20 meters, 18 megahertz, 17 meters, and 40 meters. So during the daytime, you get some pretty good QSOs. Now I asked it who's on there, and it's starting to tell me there's a KE8SEX. Good call. Is that what that is? DEX. One track mind. There's an N8LPX KE0QA. That startled me. I forgot. It's not my call. I was expecting to see me there. So anyway, I asked it who's on the bridge. There's some 8 stations back there and us. So now I can type, and it'll go out to everybody who's connected to the bridge, or I can type and direct it to one guy on the bridge. Now if you can read this, it says KB8DEX, where are you going? N8LPX says, hello from Don, remote QTH is coming up now. So you can talk to everybody, or you can talk to any one person on this bridge. So that shows, you can be sitting in your house with 1 watt, a little whip out the window or whatever, and work the world on Packet. That's the neat thing.
This bridge equipment, is that commercial, or is that something?
No, it's just a TNC that they put a ROM chip in. We hope to have a conference bridge set up at TX when we get our antennas up and all that kind of thing. So we could maybe even have a packet net, everybody just logs in on Sunday night at 8 or something like that. So anyway, you get a big old round table going here. 20 meters gets shaky about this time of night right now. So you'll see it come up and go down and whatever. But anyway, that's some of the neat things you can do without having a big station.
Excuse me, for purposes of setting max frames, pack length, and that kind of thing, is this VHF or HF packet?
This is, we're set up for VHF. The node automatically tailors pack length, max frame, whatever for HF. So the node not only, see it says N8QOOX signed on. So here somebody else just came in the bridge after us. So you'll see people come and go. But anyway, to answer your question, not only does the node change from 1200 where we are to 300 on HF, it also changes max frame. It unpacketizes all the stuff you sent and then repacketizes it. Okay, so the sysop sets up the node, and then he may tailor it between morning and evening depending upon band conditions. DEX says, here come the people. Hello, hello. So I'll say hi, Joe in Denver, and we'll see what happens. Now that'll go out to everybody's on this bridge because I just sent it to everybody. So that's some of the neat things you can do without having giant stations and big towers and whatever on packet that you can't do in any other mode.
Bill, can you change the size of those characters in any way?
On that screen?
Yes.
No.
They're set. You can't do nothing with them. Huh?
Well, we haven't figured out how to do it. That's why we hope to have next week have the overhead so we can just project it up, make it look like this.
Okay.
I just thought I'd try it just to demo another thing. You know, we've talked to Tanker a couple times, and hopefully maybe George can get down here.
He is back in town.
Yeah, he's back in town. He's on shore leave now.
Saw him too at the Hamfest.
Did you?
Yeah,
Okay.
briefly for a minute.
So he's going to try to get down here.
Heard him on 145 tonight.
Ah, okay.
Yeah, he's been on all week.
Great. Okay, let's go ahead and get into this. Can you go ahead and change the slide, whoever's the slide changer there? Now, what you need to do is keep this page in front of you. It starts off by command CMD, comma, or colon, C space W0TX-7. Okay? The thing on the board is what's on the next page. What I want to do is kind of give you an example now of what Joe has been talking about for the last 2 weeks, or does it seem like 2 years? This stuff is pretty heavy. Anyway, what this is we're going to be somebody that's going to turn on our station, get on 145.01, and watch what's going on. Okay? That's what this slide represents. The page represents the operator, in this case me. On your page, at the top, I have a command prompt, and I type C space W0TX-7, which is what I did here earlier. Now, what happens when I type C space W0TX, we, the class that are sitting out here monitoring the channel, we see this, W60AV-15. Now, let's not worry about the -15 right now. That's not really important. We'll get into that next week. The important thing is W60AV, asterisk, right arrow, W0TX-7, C, comma, P. Remember 2 weeks ago, Joe said when you type C space somebody, you send out a SABM? That's how the SABM appears on your TNC when you tell your TNC, I want to see what's going on the channel. It represents the originating address, the destination address. This is a command for connect, or SABM, and the P bit is set. In other words, we're showing the addressing and what it is. It's a connect packet, a SABM, with the P bit set. The P bit is set because we are sending that out as a command and we are demanding an answer from W0TX. If I'm sending something and I have the F bit set, I'm telling the guy, oh, I'm going to send you this, I'm going to send you something else. You don't have to answer. But if I set the P bit, then I'm demanding an answer. I'm telling the other end, I'm not sending you anything else. I'm sending you this and I'm demanding an answer. W0TX-7, our node, source, destination, W60AV, UA, final. UA, unnumbered acknowledgement, the F bit saying, okay, I'm answering. Now the important thing to notice here is this little asterisk. The asterisk is placed next to the address to indicate who you heard that from. This could have been W60AV via Digi1, Digi2, Digi3, Digi4, W0TX. And I heard Digi3. There'd be an asterisk by Digi3. That's who I heard. I didn't hear Digi2 and Digi1 and W6OAV. That's how you know who repeated this frame that you're copying. You might see the same frame repeated 3 times. The first one would be asterisk by Digi1, the second one by Digi2, the second frame by Digi3. You happen to hear all 3 of them. It's a very common question you get. How come I see the same iframe 3 times on my screen? Well, the reason you did is because you saw 3 different people passing the frame down. I think this will become clearer when we get into nodes and digis, but that's the point. To keep in mind here, wherever the asterisk is, that's the person you heard send it. Up here, my TNC heard W6OAV-15 send this frame. Here it heard W0TX send the frame, okay? Clear as mud? Says here, hello, name here is Skip in Columbus, Ohio. And DEX says, ha ha ha. We missed a frame somewhere in that because, see, so in other words, that's the other problem you may have here is the frame gets corrupted. You may not get it at all. Okay. Anyway, when this UA comes back to W6OAV's TNC, his TNC generates the second line on your page, connected to W0TX-7. So in other words, I type connect W0TX-7, the connect goes out, it might go out 3 times. Then all of a sudden, W0TX-7 hears it, he sends the UA back. That causes my TNC to say, you are now connected to W0TX-7. That came out of my TNC. Now, on the sheet of paper here, it says connected to wild node, da-da-da-da, Denver Radio Club, da-da-da-da, command line, da-da-da-da. That all comes from W0TX. We see it right here. W0TX-7, he's the one that sent it, to W6OAV iframe, expecting 0 from W6OAV, and this is my 0 that I'm sending out. See, because W6OAV hasn't sent any iframes yet, he just sent a connect request. So I'm expecting from UOAV number 0, and this is my 0. And here's the information contained in here. Now I reach the end of pack length, so I stop. W0TX-7 stops, I should say. Then he sends the next frame. Now it's number 1. Still expecting 0 from OAV because he hasn't said anything yet. And there's that command line. Okay? So that's where all that came from that appears on W6OAV's TNC.
Now, up to the 3rd line down, where the IOO is, the first O is you're expecting frame 0. The second O is what?
This is my number 0 from TX. See, in other words, TX is sending an iframe. He's telling OAV, I'm expecting 0 from you. I haven't got anything yet. This is my number 0. This is the NS. He sends it. He stops at that point because he's reached pack length. So then he sends the next iframe. See, now it's incremented to number 1. Okay, from W0TX, my number 1 now. I'm still expecting 0 from you, OAV.
Actually, that 0 is your number 1. I think that's the one you covered last week, Joe. That 0 is your number 1 transmission.
Yeah, that's your first frame because you go 0 to 7, not 1 to 8. Frame 0 through 7, So that is the first frame. I'm expecting your first frame, which is 0. This is my first frame, which is 0. This is my second frame, which is 1. See? That's what's nice about computers. You know, you're always one behind what you really think you are, and da-da-da-da, and all that. W6OAV. How's the weather in Denver? Nice. There. Whoops. Can't blame that on conditions like you can in RIDI. Packet is error-free. Anyway, W6OAV, there's the asterisk, sends a receiver ready saying, I am now expecting number 2 from you. 0, 1. The next one you're going to send me, TX, is number 2. So TX knows he got 0 and 1 because he got a receiver ready with a 2, saying, I'm expecting number 2 from you, TX. So now we're sitting there. If you look at that sheet of paper, there's the command line, and then you see that little N. That's W6OAV saying, give me a list of your nodes. And we're going to get into this next week. So this is the first iframe from OAV. Ta-da! W6OAV. I hear him sending to W0TX this iframe. And it contains the N.
Can that be a capital N or a small n? Does it matter?
No, it doesn't make any difference.
Okay.
And he's saying, I'm still expecting number 2 from you, and this is my number 0. So W0TX-7 says, okay, I am now expecting number 1 from you, and this is my number 2. 0, 1, 2. So I used an info frame to acknowledge an info frame, where here I used a receiver ready to acknowledge it because OAV hadn't typed anything yet, so I couldn't send him an info frame. But if there's an info frame ready to go, I'll use that to acknowledge rather than sending a receiver ready and then an info frame. So TX says, okay, here's my number 2 frame. I send the stuff into pack length. My number 3 frame, still expecting number 1. Okay so far? Next slide. I thought everybody went to sleep on me. Anyway, here's info frame number 4, still expecting 1. Info frame number 5, still expecting 1. I stop at this point, IW0TX. OAV says, receiver ready. I'm now expecting 6. So TX knows that 5 and 4 and 3 and 2 got there. So TX goes ahead and sends number 6, the command line again, which is at the bottom of the page there. Well, OAV decides it's time to hit the hay, so he types a B for goodbye. That is my info frame number 1 because the one before was number 0. OAV is a great typist. He typed an N and then he types a B, and that was tough. But he didn't misspell it. He's expecting number 7 because he'd already got number 6. So again, OAV uses an iframe to acknowledge an iframe. The bye tells TX he wants to go away. So TX sends a disconnect with the poll bit set saying, go away, but acknowledge before you do. I demand you acknowledge, poll bit set. OAV says, okay, boss, UA, final bit. And with that, the disconnected from W0TX appears on the bottom of the screen. Now, after Joe's dissertation, does this kind of add a little feeling to it?
I missed something here on all the commands, B, C, J, and X.
Pardon me?
I missed something somewhere. I didn't get all these commands, B, C, J, and an X, as to what they mean. Did I?
Oh, we're not going to go into that yet. That's how to run a node.
Okay.
All we did was we connected to it, and then I typed an N, which tells the node, give me a list of your nodes. So he gave this list that you see on this page. We're going to explain that list next week. And then I typed a B for goodbye. And TX said adios and disconnected me. Now next week we're going to go into what all this stuff is, how to use it, how to read this stuff. The purpose of these 2 slides here is just to kind of solidify what Joe's been talking about the last 2 weeks. iframes and P-bits and next, ready, receiver readies and and these kind of things. So don't worry about the actual text, it's the frames and how they interact.
I don't know if TNC is different in this respect, but to see this information on my screen, I need, at least on the MFJ, to use either MCOM or MCON. Can you tell me the difference?
Yes.
When I want to use SWIN?
Yes, you're leading me into my next page here. You have different levels of monitoring on TNCs. Some are a little more sophisticated than others. On the PK232 and most of the other TNCs, you have two commands, monitor and MCON. Monitor says, what do I want to monitor when I'm sitting there? MCON says, what do I want to monitor while connected? M for monitor, con for connected. Our big round table is still going on here. MCON says, what of this kind of stuff do I want to monitor while I'm connected? Monitor command allows me to define what I want to monitor when I'm not connected. For example, let's say I want to monitor all this stuff while it's going on. But when somebody connects to me, I don't want to see all this stuff. I only want to see what he's sending to me, because if I monitor all this stuff plus what he's sending, I got to sort it all out. So I would leave MCON at 0 and monitor at whatever level, and I'll get into that in a minute. So I'm sitting there monitoring all this stuff flying around, seeing who's saying what, see if anybody's talking about me behind my back, and all that. And then somebody connects to me. The TNC says, okay, I'm now in the connected mode. What does he want me to monitor while connected? Well, MCON says is set to monitor nothing. So therefore, I only see what the person types to me. Then he disconnects from me. Now I'm back to whatever the monitor command is, and I start monitoring all this stuff. Now, a lot of times, I will monitor while connected. In answer to the question Joe had earlier, if I'm pounding away, particularly on HF, I want to see how well my stuff is getting through. So in answer to your question, on HF a lot, I will turn on MCON, and I will watch all this stuff going, and I will see how fast this is incrementing, or I will see that I'm getting a lot of rejects. If I see a lot of rejects, then I start decreasing my max frame down, because I know that he's not getting the first but the second and third, so I got to do them all over again and all that kind of stuff. So I will actually turn on MCON and watch all this stuff so that I know, and I can start tailoring my parameters to speed it up. Like Joe was mentioning the other day, I went from VHF to HF, connected to my buddy in California, and I upload all the roundtable articles to him. And I said, here's the latest one, Denny, and I uploaded it. Nothing happened, and I went over and I checked and went, oy vey. Max frame 7, pack length 128. So all I could do is just disconnect, force a disconnect, change my parameters, and then start to upload again. Moved it down to max frame of 2 and pack length of 40, and they all went through. So, I mean, and I had, 2 pages of stuff, and I was right in the middle of it, and I had to disconnect it all. Anyway, on your PK232, you basically have 6 levels of monitoring while you're not connected, which is the monitor command, or monitoring while you're connected, the MCON command. If I don't want to monitor anything, I go monitor 0, which says I don't want to monitor anything. Okay, and MCON of 0, which says I don't want to monitor anything if somebody connects to me. Now, if I want to monitor for CQs and IDs, beacons, where people come up periodically in ID, I will set monitor to 1, M space 1. That tells the TNC to put anything on the screen that's what's called a UI, unnumbered information. Remember that guy? So therefore, I can periodically look at my screen and see, oh, so-and-so called CQ 3 minutes ago, so-and-so ID'd, whatever, okay? That's why it's not necessary to sit there and bang away CQs one after the other, because if somebody's watching for it, they'll periodically look at the screen and they'll see the first one you sent. If you send 20 of them in a row, they'll probably say, oh, the heck with that guy. Forgot, I had my mic on. So anyway, Weather is clear and 45 degrees in Ohio, if anybody cares. And they're all yakking Columbus. Columbus. But anyway, if you can read it, you can see how you get the different call signs on the left and what they're saying. There are a bunch of guys yakking. Anyway, if you want to see CQs and beacons, you make monitor 1. If you want to see CQs and beacons while you're connected to somebody, and I do this an awful lot, then you leave MCON on 1. And that way you see the text coming in, like on that page you were looking at earlier, and right in the middle of it you might see a CQ from so-and-so, this sort of thing.
I have a question on this. I know I can ask for this, but I have a 232. Is there any way, the way it seems to work for me, the only thing I will see on my screen is I'll see an M down there, or that I have something. If I'm going to be talking with somebody connected, then I'm on like channel O. And the monitor channel is the only place that all that other stuff appears. So then you're going back and forth, or is there some way that you know of to actually have that stuff come in on your channel that you're talking on while you're connected? So you don't have to keep going back to the monitor channel to pick up these
Or you're running some kind of a software package.
compact.
Oh, okay. That's a function of your software package. I'm not familiar with that one.
Okay,
See, if you're running a dumb terminal mode,
then you'll see it all.
then you'll see it all, and the PK232 will come up and it'll say channel 0 call sign da-da, channel 1 call sign da-da, you know, that sort of thing. If you're running like Packet Gold, which is what I run, then you have one window that's all your monitor stuff. You have a window that you're talking on, another window you're talking on, and if you're on one channel and somebody sends you something on the other channel, it'll say data on channel 1, you go over there and you look at it. If you want to look at the monitor, you go to the monitor window. See, so that's a function of your software, and I'm not familiar with that one. Joe, you ever heard of that one?
No.
Anybody else?
I think I can answer that one. I use
Great.
with the 232. You hit the function key 9, brings up your parameter screen. And in mid-operation, you can change anything. Yeah, that's the dark one. But if the functions operate the same, well, yeah, but if
How do you
functions
know where
operate
some of
the
these,
same, they must
some of
be
these
able to
hams are located, like WD7, AJP?
Well, let's get into that when we get into nodes. So ask it when we get there, because I don't get sidetracked here, and then we'll. Okay, we just had KS8L sign on, and he's in Canal, Winchester, Ohio, if you know where that is, 15 miles southeast of Columbus. He says, "Hello, Skip," and things like that. Having TVI problems.
What'd you send him?
I just told the guys in the bridge that we're demoing this to the Packet class. This is a little one-sided because I'm really not talking to these guys, and every once I shove something out there, so, but you get used to that. Anyway, level 1 is for UIs, unnumbered information frames, and those are used to carry CQs, beacons, things like that. Or remember we talked about roundtables? If you want to have several guys carry on a roundtable, they would all set their MCON and their, well, it depends on the mode, their monitor and their MCON both to 1. Okay? So what that means is anytime anybody types something in, they're not connected, they just type and hit a carriage return, that goes out as a UI frame. Because if I were connected to somebody, then every frame I send out, I'm expecting acknowledgement back. But if I am in the unconnected mode, in other words, I got the command line and I just say, "Hi, Bill in Denver, carriage return," it goes out as an unnumbered information frame. I'm not expecting an answer back because I'm not connected to anybody.
So that would be the only way to have roundtable.
Yes. You set your monitor to 1, and if you're going to be connected or somebody's going to connect to you, you might want to set MCON to 1 so if they connect to you, it won't shut off your unnumbered thing. So that's how you do it. If you and myself want to have a roundtable, we would all set our monitor to 1, and I would type, and you would see my unnumbered information frame, and you would see my unnumbered information frame. You might answer me, and he'll see it, and I'll see it. The only disadvantage is, if you type, and the wife happens to fire up the vacuum cleaner, that frame gets corrupted, and I don't see it, and you don't know it, but you get it because you didn't get corrupted. So that's the disadvantage on a roundtable. On unnumbered frames, you say, how's things going? And if he doesn't answer, you say, how's things going? Again.
Could you parlay that in with the use of the multiple channels? Where like on channel 0, you're running the way you just described, roundtable.
Okay.
But on channel 1, you connect with one of those.
Right. Then I would want MCON.
Back and forth, you could sort of whisper in that one fellow's ear, if you will.
Right. In other words, we have these, remember we talked about these logical channels.
Yeah.
I could set up a logical channel to you. I could be on my 0 to you, my 1 to you, and then I would type something to you on my logical 0. You wouldn't see it unless you had the MCON on. If you did, then you'd see it. You know. And then, if I wanted to send an unnumbered information frame out to both of you, let's say we are actually having a roundtable. Anytime I would go to an unconnected channel, like channel 2, I'd be in the command mode and I'd say, boy, did you hear what he said? And then, you know, and that would go out to both you guys. But if I went to channel 0 and said, did you hear what he said? Only you would get it. Now, if he has his monitor on, he'd hear it. He'd see it. But if he has his monitor or his MCON, I should say, to 0 or just to 1, then he wouldn't really see that. So you could run roundtable while you are running several logical channels. Does that answer?
Is this being done through the software or through the TNC?
Through the TNC. The software makes it a lot easier to do. Well, the software automates things. For example, let's say I got a channel 0 here, channel 1 here. Then I just hit a function key, and it puts me on channel 0, and I type. Hit a function key, puts me over on channel 1, I type to him. And then I go to hit my function key again to go to an unconnected window and type something, and that goes out as a UI frame, as opposed to actually issuing the commands to the TNC to force it to change channels. For example, if I'm using a dumb terminal, then I got to tell the TNC everything I want it to do. I go Control-C to put me in the command mode, and then some special character that you picked out. For my TNC, I have a plus. So I go +0, and that puts my TNC onto channel 0. Then I do a K to go back to converse mode. Then I type on channel 0. And now I want to go to channel 1. I do a Control-C to get me back to the command mode. +1, which now moves me to channel 1. Do a K to go back to the converse mode. Then I type to you. And then if I want to send out a UI, I'd go back to the command mode, do a +2. Now my channel 2 is not connected to anybody. And I say, hello out there. And that goes out as a UI frame. So I got to tell my TNC each little step to do. Well, if I have a software package, it's just a function key in most of them. I hit a function key that says you're on 0. Hit it again, I'm on 1. So it's issuing all the commands for me. It simplifies all this stuff. And you'll see this in about 3 weeks or so when the guys start bringing in the various packages that we're going to demo for you. Did that answer your question?
On your PK232, your 1 is on, whereas on my MFJ, I might have to say on or off.
Well, I'm going to have somebody that's familiar with MFJs explain that a little bit.
0 and 1, what you're talking
Well,
about.
mine's even more than that. The 232 is even more than that. The 232 is a little more sophisticated. Level 1 says, I only want to see unnumbered information frames. Level 2 says, I want to see unnumbered information frames as well as information frames. I want to see who else is talking on the channel. Okay? I want to see only information frames. Level 3 says I want to see unnumbered information frames. I want to see information frames, and I also want to see anybody that's issuing a connect or a disconnect. Okay? Level 4 says I want to see the UAs and the DMs as well as all the rest of the stuff. Level 5 says I want to see all the different frames. Level 6 says I want to see all the information frames plus this stuff. Level 6 is great when you're doing troubleshooting. It's a data scope.
Somewhere you've got these levels written down?
No, because I figured if you had the TNC, you'd be familiar with it. On the MFJs, because each TNC is a little different. On the MFJ, you turn monitor on and off and MCOM on and off, and then you have a pass-all command. Now, does anybody know on the MFJ, can you define levels like this? I don't think you can. That's why I like the 232, because I can pick what I want to see when I go into this.
Done a little bit different. They've got an M-all node, turn on and off. You've got M-com, which gives you your protocol information. And then you've got M-con, which you see connected.
Okay.
You see other packages while you're in connected mode. And then there's a BBS. There's several different ones, all of which are either turned on or turned off.
Well, most TNCs have some form of monitoring the protocol. And some are a little more sophisticated than the others, like the 232. You can define at what level you want to see. And you'll find yourself doing this a lot to find out what's going on. Like I mentioned, sometimes if I don't know whether I have my max length and pack length set right, I'll actually watch it while I'm sending it. And if I get a lot of rejects coming back, or I see that the frame rate is real slow, or I see it's really, I send 3, it acknowledges 3, da-da-da-da, I can tailor it as I go along, and this sort of thing. Many times, somebody will call up and say, I can't connect to so-and-so, or I'm getting garbage or whatever. I'll go into this mode so that I'm bridged onto the line as they're talking, so I can watch them and see who's not answering, or who's doing funny things, or who's sending out garbage. Things like that. Because RF can get in your TNC and cause garbage, particularly on HF. If a garbage goes in, and then the TNC makes a packet out of it, he thinks that garbage is valid data, and he says, here's this packet, and this garbage in here is valid, that's what came in. And the other says, oh, okay, that's valid garbage, throws it up on the screen.
Arvada Aries, I downloaded a situation explaining how to run a conference bridge the other night. And when you're in the conference bridge, it accepts up to 8 people. Are you still on an unnumbered frame situation?
No, you're connected to the actual bridge.
Actually connected, but
everybody's
reading the same thing.
Yeah, we're going to go into this when we get into the nodes and all that, because see right here, see now here, look at this. Let me just digress for a minute. Connect request KC0CZ-15. We have users set to 1, and we are on channel 0. So he sent a connect request to us, and we sent a DM back to him, which caused his screen to say KE0QA busy. And it put a connect request on here so that we know he tried to connect. So I could go to channel 1, even though I got users set to 1, I could go to my channel 1 and connect to him. Because users define how many people can come in. So that's exactly what you see. We talked about this about 3 weeks ago or 4 weeks ago. Okay. Anyway, on the conference bridge, it's got 8 logical ports, and each person connects to his own port. And then when you send something into that port, it goes to all the other ports unless you type a special command and tell it which port you want it to go to. We'll get into that a little bit more on here. See, we're set up just to copy what everybody's sending, but we have our own individual link. Okay, I'm connected to TX. TX is connected to KS8L-7 in Ohio. KS8L-7 is connected on 2 meters to the node. So they're individual links, so we'll get more into that.
Well, what I picked up off of that, there's a simple command for talking to 8, And then there's one other command for talking to any one of the others.
Yeah.
All of this.
Yeah, we'll get into that. Okay, any questions on this? This kind of wraps up the protocol business. Like I mentioned at the beginning, if you understand what's going on, not only can you optimize your station for maximum throughput, you can help other people troubleshoot what's going on. That's why it's kind of important to understand all of this stuff. And as you watch it, it'll become clear to you. Next week, we're going to start putting live stuff up here so you can see it. And I think it'll come more clear. And we're going to talk about how to use the nodes and that sort of thing. Let's go ahead and flip to the next slide. You hear a term called Windows. Joe's already talked about this. It's called MaxFrame. A lot of people refer to it as a window. In other words, what is my window size? How many frames can I send out before I got to stand back and wait for an answer? Okay? And we have set it up for 2. So I say, okay, this guy's typing real fast. He sends out 0 and 1. 0 and 1 go out. He stops. He's waiting for an acknowledgement. He gets the acknowledgement saying, I'm expecting number 2. I've got 0 and 1. My window rotates these 2. I send out the next 2. I wait. I get a receiver ready back, or it could have been an iframe, like we saw before, saying, okay, I'm expecting 4. I got 2 and 3. We rotate our window around. So you can see as we go around, you never can have a window bigger than 7, because otherwise you'd be 0 all the way back to 0, so you'd have 2 zeros hanging out there, and boy, would that confuse things. So your window is 1 to 7. It's just kind of a graphical representation of what Joe was talking about earlier there. Okay, any questions? Next slide.
Are you reading the dark area of that circle or the light area?
The light area. The little light area. I took these in a hurry and they didn't come out real well. Kind of show you what some of the lights are. They vary from TNC to TNC, but they're basically the same. This light here is on. It's called the command light. That says that you're in the command mode. In other words, the channel that I am on is not connected to anybody. So if I'm sitting on channel 0 and a UA comes in, I'm sorry, a SABIN comes in from somebody, I will immediately respond with a UA, command light will go off, and the connect light will come on. I automatically switch to the converse mode. If I start typing, it goes out. Now, once I'm connected to somebody, let's say I'm typing away and I realize that, hey, my pack length is too long, I can do a Control-C, which will turn off my connect light, put me back in the command mode. Then I can type pack length 20. Maybe it was 128. And then I do a K for converse. The command light goes out and I go back to the converse mode. Actually, these are tied together. Next one. Okay, there I'm in the converse mode. Next one. Okay, this is the connect light. I got a little tied up here. I wasn't expecting to get this far tonight. Command mode, converse mode, connected. Okay? So in other words, let's say that I'm on channel 0 and I'm not connected to anybody and I'm in the command mode. If I do a Control-C and then do a K, I go from command to converse mode, but I'm not connected. and then I type hello out there in radio land, I send out a UI because I'm in the converse mode on a non-connected channel. If I do a control C, I go back to the command mode, that goes out, and let's say somebody connected to me on channel 1. If I told my TNC to go to channel 1, then the connect light would come on. I'm still in the command mode, so I do a K, my converse light would come on, so now I'm on the connected channel in the converse mode, and then whatever I type will appear on his screen. Now if I decide, in that example I used earlier, where I want to decrease the path length, I would do Control C. That would take me out of the converse mode, put me back in the command mode. I would type path length whatever, because the TNC now knows that I'm talking to it, so it's not going to send this out because I'm in the command mode. Type path length 20 or whatever. Then I do a K. That goes out because I go out of the command mode, I go back to the converse mode. So let's say, for example, I had 2 channels going, channel 0 and channel 1. And I'm over on channel 1, and I'm typing away, and the fellow on channel 0 disconnects. Okay, since I'm on channel 1 and I'm connected, my connect light is on, my converse light is on, because we're talking. Now, if I were to go to channel 0, in other words, I do Control C to go to the command mode, which turns on this light, turns off the converse mode, and then I go to channel 0, both of these lights would be out because channel 0 is not connected to anybody. So if I go back to channel 1, the connect light will be on, the command light will be on, because I had to issue the command to get to channel 1. Then I do a K to go back to converse mode, the command light goes out, the converse light comes on, and I can type away. Now keep in mind, I'm on channel 1, there's nothing on channel 0, and then all of a sudden, Les back there connects to me, and it says, "Hi Bill, how are you doing?" My lights don't change here. I have to go back to the command mode with my Control C, move over to channel 0. That'll turn that on because I have a connect on channel 0. Then I have to do a K to get back to converse mode so that I can talk to Les. Now let's take another example. Let's say that I talk to Les, and then he says adios, and I go back to channel 1, I finish my QSO, and I sign off, and now I'm not connected to anybody. I'm sitting on channel 1. Now Les decides to connect to me again. He connects to me. And on my screen I see, "Hi Bill, how are you doing?" I look at my lights. That one's on. Those are not. Okay? Well, at this point in time, if I type a K to go to the converse mode, the command goes off, the converse comes on, but my connect is not on because I'm on channel 1. And if I type, "Hi Les, how you doing?" and I see this all the time on Packet, it's going to be an unproto that goes out. And if Les isn't set up to monitor unproto, he won't know I tried to talk to him. This is a very common mistake. People see the data come up on the screen, "Hi, how are you doing?" and they sit there and go to the converse mode and try to talk to him and don't look at the lights. Don't realize they're on the wrong channel and everything they're sending is going out as UIs. Okay, so in this case, when it says, "Hi Bill, how you doing?" I look down and I see that I'm in the command mode, my connect is off. I know that I'm not on the channel he's on. So I do a Control C, and on the 232 you can do a CS, which says, "What's the status of all your 10 channels?" and it'll come up and list all the 10 channels and say who's connected where, and I go, "Oh, Les is up on channel 0. So I do in my case, a plus. You can define what your switch character is, +0 in the command mode. All of a sudden this light comes on, and then I do a K to turn off my command and turn on the converse, and I say, "Hi Les, what you up to?" So that's one thing you got to remember. You've got, most TNCs usually have 10 channels, and you can be on any channel you want, but when somebody connects to you, he's going to pick the first available channel. 0. Okay? So you got to be very careful on that. I see that happen all the time where had got half a QSO going.
That's when you go to the telephone to see if it got through.
Right. N8 LPX uses a hammer and a butter knife to keep his Yaesu on frequency. Anyway, you can see the round table still carrying on here. Okay, does that make sense? You got to remember, you got logical channels, and you got to remember when you want to talk to somebody, you got to be on his channel, and you've got to be in the converse mode. Next slide. Okay. Now, you'll have another light called STA for status. What this is I'm in the connected mode, so I'm on a channel that's connected to somebody. I'm in the converse mode, and I've typed, "Hi Les, how's it going?" Hit the carriage return. My TNC sends it out. Doesn't get an answer from Les. Sends it out. On the third time, I get an acknowledgement back, either an information frame or a receiver ready, that it got the packet. Then this light goes out, and then this TNC throws away that packet because it has been acknowledged at the other end. Now, if my pack length is sitting at 40 and I'm typing real fast, and I hit the carriage return, I may have 3 packets sitting in queue. The first one goes out, it gets ACT. The second one goes out 2-3 times because I got my max frame at 1. It finally gets ACT. The third one goes out 2-3 times, finally gets ACT. Then at that time, the STA goes out. So it takes an acknowledgement to turn that light out. If you're sitting there wondering how come the light's not going out, maybe that's when you turn MCON on to see what's going on. Is he sending you rejects? Is he sending you FMRs, remember frame rejects? Is it just taking a bunch of tries? Most TNCs have some form of STA light. Most of them have a send light too. That's when your push to talk turns on. So you'll be here in the connected mode, converse mode, and you'll see this going on, off, on, off, on, off, and all of a sudden that goes out. The other thing we talked about, and this is where turning on the protocol is, I'm sitting on my channel 0, Les connects to me, my connect light goes on, I go to the converse mode, I say, "Hi Les, how's it going?" On, off. I have a connected message, by the way, on my screen. Remember when the Sabin came in? These turned on. I'm sending a UA out, and I'm typing, "How you doing?" I see this on, off, on, off, on, off. This is staying on. So as usual, I call Les on the phone and say, "Les, what the heck's going on?" He's saying, "Well, you're not connecting to me." I say, "Yeah, I'm connected." Well, yeah, the Sabin came in, put me in the connected converse mode, and I typed, "How you doing?" And that's sitting here in the buffer, and I'm sending UAs back, but he's not hearing them. So as far as he's concerned, I'm not even on the frequency. As far as I'm concerned, he's rude, he won't answer me. This is a very common thing. So I turn on the monitor, and I see him sending me Sabins. He's not hearing my UAs, that's the problem. So I call Les up again. "Les, turn your beam my way." This is where all this protocol monitoring really comes in handy, so you can see what's going on. Okay? Because that's a very common complaint. I see this going on all the time. Sabim, 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 Sabim.
What does the error mean above the connect?
That has to do with Amtor and other stuff.
Oh.
This stuff is all Amtor and all that.
Is it like regular radio, you can hear, but it doesn't mean that someone can hear you?
Right. You really get this if you're running an HT, or low power. Here's this guy, he's got 100 watts coming at you, and you're going with your little 1 watt, See, and what'll happen, remember our retry parameter? He'll send a SABM for whatever retry you have, and then he'll send a disconnect, and all of a sudden your lights go out. Say, well, that son of a gun, now he didn't talk to me. He hung up on me. Well, you know, the retry, he only hit 7 times, and he gave up. Any other questions here? So we're getting.
Touch on the one last button over there.
Oh, this one?
Yeah.
Yeah, that's your multi-connect. If that light's on, then you've got more than one channel set up. So in other words, I'm on channel 1, and I'm connected to Les, and then Dick connects to me on channel 0. That light will turn on to tell you in the multi-connect mode, be careful what channel you type your stuff on. Or if I set up 2 connects, like I set up one to Dick and then one to Les, and I want to tell Dick, boy, that Les is, he's a real AMer, isn't he? I got to make sure with the multi-light on that I'm on the right channel. Okay. Next week, why don't you just flip up the slide here? I think this is the end of it. No, this shows when I'm in the connected mode, but I went from converse to command. So that tells me if I type something, the TNC is going to think it's command. It's not going to go out over the air. Okay, next one. Okay, next week we start with all the fun, good stuff. This is how to, we're going to start answering a lot of the questions you've been asking for the last 4 or 5 weeks. You know, what is a digi, what is a node, what is a K node, what is netrom, what is the net, how to run all the commands, why you don't want a digi unless you have to, you know, when would you want a digi, and all these kinds of things. So we're going to get into the fun stuff. What I'm hoping to do is to get into it enough so that the following week, which would be the 3rd, I can have either Dave down here to describe or demonstrate Hostmaster with the cam, or Don W9SL to demonstrate Packet Gold. So I'm hoping we get that far. The 3rd is my 30th wedding anniversary, so I probably shouldn't be here. She's been around ham radio for too many years. As I was telling somebody earlier, when she and I were dating, I was pinned to another gal at the university, and she was engaged, and we were just kind of dating, you know, platonically. And I told her one time, never marry a ham, because in those days I had dynamotors, you know, I mean, to run mobile in those days on HF was something. And every once in a while she brings that up. Should have listened to you. So I'm hoping we get to that point where we can have somebody fill in for us, because Joe's going to be up skiing or playing or something, so he won't be here. So. Nice romantic evening.
I'll send her an anniversary card.
I'll put a candle here. Anybody got a candelabra? Glass of wine? Okay, well, if there's no questions, we'll call if you want to come up here and see what's going on.